All right. So now we're going to be looking at how do we differentiate logarithmic functions. So how do we differentiate log functions? So consider if y is equal to log to base e of a function of x. Now the log to base e of a function of x. Now base e, log to base e, they generally write this as ln. So if you look in the top right hand corner of your calculator, you notice that you say log, that's natural, that's log of base 10, but there's ln too. This is now log to base e, right? So whenever you have a function as y is equal to ln a function of x, then dy by dx is f prime of x over f of x. So consider this example, y equal ln x cubed. Your function of x is x cubed. And so let's do part I right here. If y is equal to ln x cubed, so y is equal to ln x cubed. Y is equal to ln x cubed, then dy dx is equal to f prime of x, which is when you differentiate x cubed, when you differentiate x cubed, you get 3x squared, bring down the power 3, subtract 1 from the power, divided by x cubed. And so what we get is 3x squared over x cubed, and the x squared from the numerator cancels the x squared from the denominator. And so what we get is 3 over x. And so if y is equal to ln x cubed, we differentiate y equal ln x cubed to get dy dx is 3 over x. The next thing to talk about is consider y is equal to ln the sine of x squared plus 1. Y is equal to ln sine of x squared plus 1. So your function of x is the sine of x squared plus 1. And so if your function of x is the sine of x squared plus 1, how you're going to find your derivative is you're going to say dy by dx, it's equal to, what is the derivative of f of x? What is it? So this is your f of x. What is your derivative of sine x squared plus 1? Your derivative of sine x squared plus 1, your f prime of x, would then be, when you differentiate sine, you get cosine, and so it would be cosine of x squared plus 1. But then you have to times by the differential of what's inside the bracket, and the differential of what's inside the bracket is 2x. And so dy by dx then is going to be 2x times the cosine of x squared plus 1 times the cosine of x squared plus 1, and that is being divided by, that's your f prime of x, and it's divided by your f of x, which is your sine x squared plus 1. This is your sine x squared plus 1. Now the next thing you can do is simplify this if you want, because cosine over sine is cotangent. And so this simplifies to be 2x times the cotangent, cos over sine is cotangent, times the cotangent of x squared minus 1. So that's how we would differentiate y equal to ln sine x squared plus 1. Now, let's consider how you would differentiate y equal to a to the x, right? So y is equal to a to the x, right? Now, continuing with differentiating logarithms, we can differentiate y equal to log to base a of a function of x, right? To differentiate y equal to log to base a of x, well, we don't know how to do this, right? We really don't. But we just found Now, if you watch the previous video, we found how to differentiate when it's log to base e. And so what we can do is apply laws of logarithm and change this base to base e. So remember that what is the change of base rule in logarithm, right? So let's put it up here. Right? We know the change of base rule. Change of base law. The change of base law tells us that we can write log of some base b of some number n. We can rewrite that as log to a new base c of the number n divided by log of the new base c of the old base b. And so following this step or this rule, we can write that this becomes log to base e. We're going to change it to log to base e of x, and that is being divided by log to base e of a. Now log to base e of x, as we know it, that is ln x. And so we have y is equal to ln x over log to base e of a is ln a. So we can rewrite y then as 1 over ln a times ln x. So 1 over ln a times ln x. Now 1 over ln a is just some constant. Think of this as k. Think of it as k, some constant, k times ln x. And so when you're differentiating now, y equal 1 over ln a times ln x, what we then get is, when we differentiate it, we're going to get that dy by dx is equal to, we keep the constant, 1 over ln a is a constant, and so 1 over ln a times the derivative of ln x. Remember, when we differentiate ln x, as we saw previously, we get f prime of x, and the derivative of x is 1, so it becomes 1 over x. And so when we differentiate y equal to log to base a of x, the result in this case is just 1 over ln a times 1 over x. Alright, some people might go ahead and write it as 1 over x ln a. Right? For simplicity, we could just rewrite this as 1 over x ln a. 1 over x ln a, or ln a times x. Either way is fine. So here's an example. It says find dy by dx for when x equal 10, for y equal log to base 5 of 6x, and log to base 10 of x. So for the first one right here, y equal log to base 5 of 6x, dy by dx is going to be equal to, now it's going to be equal to 1 over ln a. A in this case is 5. So it's 1 over ln 5 times the derivative of ln this now. So this is now 6x. How do we differentiate 6x? So to differentiate 6x, we get 6. And so it is 6 over 6x. And so the result of this is going to be 1 over ln 5 times 1 over x. And they wanted dy by dx when x is 10. And so what you do then is plug in the value x being 10. So we can write when x is 10, when x is 10, when x is 10, dy by dx, you can call it y prime. Y prime is the same as dy by dx. So for space, I'm going to write y prime. Y prime is equal to 1 over 10 times 1 over ln 5. So it's 1 over ln 5, 1 over ln 5 times 1 over 10. So you may put this in your calculator, and that gives you the derivative of y equal log to base 5 of 6x. Some people might go ahead and do it the long way by converting this to base e and then differentiating it. But by us knowing what the result is going to be, we could just use the result that we know it will be. All right, now let's look at the second one. It says log to base 10 of x, right? So let's do it the long way for this one, just for showcasing the real thing, right? So y is equal to log to base 10 of x, and so y is equal to log to base 10 of x. We may rewrite this as, in terms of base e, this is ln x over ln 10. That's what it is in terms of base e. And so what we're then saying then is that dy by dx is going to be equal to, when we differentiate 1 over ln 10, what are we getting? That's a constant, so we just factor out the 1 over ln 10 and then multiply it by the derivative of what is ln x, because ln x is what we're really differentiating, and the differential of 1 over ln x is 1 over x. And so that's what we get. So now to find when x is 10 now, we just put x as 10 in our calculators. So when x is 10, to get dy by dx, we're going to then get that y prime is equal to, replace x with 1 over 10, and so we get 1 over ln 10 times 1 over 10. And whatever that is in your calculator, that's dy by dx when x is 10. Very easy stuff. All right. Now we're looking at differentiating exponential functions. To differentiate exponential functions, if y is equal to e to the f of x, then dy by dx is going to be equal to f prime of x times e to the f of x. That's dy by dx. dy by dx is f prime of x times e to the f of x. That's how we find the first derivative of a function y equal to e to the f of x. Now let's look at these examples. Part 1 said to find the derivative of y equal to e to the sine x. Now sine x is like your function of x right here. This is your f of x. And so what you end up get then is y is equal to e to the sine x. That's your function of x is sine x. And so you find the derivative of sine x, and the derivative of sine x is cos x. And so what you get then is dy by dx. dy by dx is equal to the derivative of sine x, which is cos x. And then you multiply it back by, of course, e to the sine x. And so that's how you differentiate exponential function. Let's look at the second example. It seems to be a little more complex. And so for the second example, we have y is equal to e to the x squared minus x plus cosine x. And now we want to find dy by dx. So to find dy by dx, or y prime, dy by dx is equal to, your function of x is, cosine x is in the numerator. So to find dy by dx, this is your function of x, everything in the numerator here. So to differentiate everything in the numerator here, when we differentiate x squared, we get 2x. When we differentiate x, we get 1, so it becomes minus 1. And we differentiate cosine x, we get minus sine x. So this is your f prime of x. And remember, it's f prime of x times e to the f of x. So it's times e to the x squared minus x plus cosine x. And that's how we differentiate exponential functions. Easy.